Welcome dear audience, students and scholars. Here I am Dr. Amjad Ali. In this video we will learn inflation and interest rate. Dear scholar, interest rates are among the most important macroeconomic variables. In a sense, they are the prices that link the present and the future. Here we discuss the relationship between inflation and interest rates. Two interest rates, real and nominal. Although we have discussed the real and nominal interest rate in our previous session, but here we are going to link real and nominal interest rate with our inflation rate. So suppose you deposit your saving in a bank account that pays 8% interest rate annually. Next year you can withdraw your saving and accumulated interest. Are you 8% richer than you were when you made the deposit a year earlier? Okay, the answer depends on what richer mean. Certainly you have 8% more dollars than you had before, but if prices have risen, each dollar buys less, and your purchasing power had not risen by 8%. If the inflation rate was 5% over the year, then the amount of goods you can buy has increased by only 3%. And if the inflation rate was 10%, then your purchasing power has fallen by 2%. The interest rate that the banks pays is called the nominal interest rate, and the increase in your purchasing power is called the real interest rate. Okay, if I denote the nominal interest rate or the real interest rate and phi the rate of inflation, then the relationship among these three variables can be written as R is equal to I minus pi. The real interest rate is the difference between the nominal interest rate and the rate of inflation. Fisher effect. Okay, rearrange the term in our equation for real interest rate. We can show that the nominal interest rate is the sum of the real interest rate and the inflation rate. So our equation become as I is equal to R plus pi. This equation written in this way is called the Fisher equation after the economist as Gregory Fisher, and the lifespan from 1867 to 1947. It shows the nominal interest rate can change for two reasons: because real interest rate changes or because the inflation rate changes. Once we separate the nominal interest rate into two parts, we can use this equation to develop a theory that explains nominal interest rate. The real interest rate are just to equilibrate saving and investment. The quantity theory of money shows that the rate of money growth determine the rate of inflation. Fisher equation then tells us to add the real interest rate and the inflation rate together to determine the nominal interest rate. The quantity theory and the Fisher equation together tells us how money growth affect the nominal interest rate. So according to the quantity theory, an increase in the rate of money growth by 1% causes a 1% increase in the rate of inflation. According to the Fisher equation, a 1% increase in the rate of inflation in turn causes a 1% increase in nominal interest rate. The one-for-one relation between the inflation rate and nominal interest rate is called the Fisher effect. Okay, the two real interest rate, ex-ante and ex-post. When a borrower and a lender agree on a nominal interest rate, they do not know what the inflation rate over the term of the loan will be. So therefore, there must be distinction between the two concepts of real interest rates. Real interest rate that the borrower and the lender expect when the loan is made is called the ex-ante real interest rate, and the real interest rate that is actually realized called the ex-post interest rate. Okay, although borrowers and the lenders cannot predict future inflation with certainty. They do have some expectations about what inflation rate will be. So let we have a pi denote the actual future inflation, and E by the expectation of future inflation. The ex-ante real interest rate is equal to we can say I is equal to E pi, and the ex post real interest rate is pi I minus pi. The two real interest rate differ when actual inflation pi differs from the expected inflation e pi. Okay, how does this distinction between the actual and expected inflation modify the Fisher effect? That is a more important question. Okay, clearly nominal interest rate cannot adjust to actual inflation, because actual inflation is not known. When nominal interest rate is set, the nominal interest rate can adjust only to expected inflation. The Fisher effect is more precisely written as I is equal to R plus E x e pi, sorry. The ex-ante real interest rate R is determined by equilibrium in the market for goods and services. The nominal interest rate I moves one for one with change in expected inflation E pi. So this is all about inflation and interest rate. So see you with another video. Ciao.